In the name of God, hello class. We continue the previous section. We explain about some explanation of GA, and we explain about fitness proportionate selection. This method is used for selecting offspring for the next generation. If we go to the previous uh, previous page, we explain about some method of selection, and selection may be based on random. In the random selection, you can select only random, and you must use selection pressure. Selection pressure means that you don't select by random, you select by the fitness. And for example, you can use the fitness to select with higher probability. In this example, you can see that this value has this fitness, this value has this fitness, higher fitness, and lowest fitness is here, and this value has this fitness. The probability is the division of fitness divided by summation of all of this fitness. It is here, it is here, and it is here. If you want to select 4 uh, number of element, you can multiply this probability by 4, and the expected count uh, is here, 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 and here. The count is a integer, but these values must be round to the integer. So this value round to 1, this value round to 2, this value round to 0, and this value round to 1. It means in the next generation, if you use fitness based random selection, the combination of fitness and random selection, you may have one element of this individual, two elements of this, it is 13, two elements of 24. We don't have this element because it is low fitness, it has low fitness, and one element of this. So in the next generation, you have this population with 13, two element of 24, and one element of 19. We want to explain about this fact that we want to use a selection that select more fitness elements. Expected number of copy of an element or individual is ENI. It is mu. Mu is a population size that in those example is 4. Mu is 4 because the population size is 4. Fi is the fitness of element I, and this F is it is not true. It is a summation of fitness. Summation, sum of all fitness. It is wrong please correct this page. This page have a rank. It is a sum of all. So in the I go to the page. In this page, it is here. It is F. It is summation of all of fitness, and you divide the fitness by summation of fitness, then multiply by uh, population size. It is a 4. So this formula is it is here. E is the expected count of number of each element that is obtained by this formula. It is named as a SUS, or a special selection of RWS. In RWS, you divide for example, a circle or roulette according to each fitness value. Then you round, for example, if you have 3 elements, you round this roulette 3 times, and each times each element near this sign select for the next stage. So all of the elements have to select for the next generation, both A, B, and C. But in SUS algorithm, you have 3 number of population. We have 3 population, 3 elements, so you have 3 sign, and you round first only one time. You round this circle one time, and each time each element near the sign select. For example, in this shape you have A, because it is A, you have C, and you have C. You have ACC for the, you select for ACC for next generation. This method guarantees that for the best elements such as C, we have any I number of, for example, C or each, it is around, for example, 1.7. For example, the floor of 1.7 is 1 and the seal of 1.7 is 2. In other words, SUS guarantee that we have at least one element of C, or maybe have 2 elements of C. It is named SUS. But in RWS, or roulette wheel selection, NI is 0 for all elements, and it is N, all of the elements. But for SUS algorithm, NI is between floor expected NI and seal expected NI. Floor is, for example, if you have expected is here, the floor of this value is 1 and the seal is 2. In other words, if this formula provide this value, SUS algorithm provide 1 or 2 elements of that values. But in RWS, it is between 0 and n for all of the elements. So in SUS algorithm, it is guaranteed that at least some number of elements exist in the next generation for high fitness value. These two types of selection is named fitness proportionate selection. This two type of selection is based of fitness. It is combination of fitness and random selection. If you use a random, all of the elements have the equal chance to select. But when you use the fitness proportionate selection, the more value of fitness, the more value of chance to select for the next generation. In other words, high fitness element has more chance to select. But this type of selection, these two type of selection have some problems. One of the problems is named as a premature convergence. The other name of this idiom is local minima, trap to the local minima. It is because all of the population is same, and it is named when you select only the fitness, high fitness value. After some loop of algorithm, all of the elements are the same, and this name as a premature convergence. It is named because the diversity of this element is low. It is one of the problem. It is named as a local minima, trap to the local minima. And the other problem is all of this value is similar fitness. For example, if you have a fitness between, for example, 1 to 50, most of these elements have fitness near 50 because we select high fitness after some loop of algorithm. These values are very similar to each other, and so we lose the selection pressure. The selection pressure means the distinction between the individual. If all of the individual have the same fitness, this or selection is same as random selection, and the random selection has very low selection pressure. And another problem is high susceptible function transposition. We explained about this problem. We can solve these two problems by scaling and changing sigma scaling. For example, for these values, you can change the fitness by this formula. If beta is the lowest fitness, such as this, if you subtract the lowest fitness by each fitness, you have this, you have this, you produce this, you produced this, and you produced. It is the or fitness after scaling or windowing. So you can see this value are different valued, such as, but these values are very similar. So we can solve this problem by scaling or windowing. Another solution to solve this problem is to use sigma and c fixed value by select the maximum between fitness and the scale of the sigma. And these two types of change the fitness to produce better fitness. The last problem show here. If you use fx as a fitness function, but when you change the element, this fitness change, such as this line, the red line for some element and the black line for the other element. But the chance to select is change. You can see the change. For example, element R is change because the fitness have the transposition problem. One of the problem of fitness is change because all elements are change. It is the repeat of this slide. So we must use some selection to solve these problems. One of this method is rank-based selection. The rank-based selection is the sorting method to select best individual. If you have some population or element, for the first time you sort this value, then select the highest fitness value. This method is named as a rank-based selection. Rank-based selection select the element without any random, but in FPS or fitness proportionate selection, we select both based on random and fitness. But when you use the rank-based, you only use the fitness for selection. The higher fitness, the more chance to selection. If you have a mu number of individual, you can sort this individual from 1 to mu, and you can select some of them for next generation. One of the disadvantage of this method is sorting overhead, because the sorting operation is a time consuming method, and it causes our algorithm execute slower. We have some rank selection. First of this is linear selection. It is a linear selection, and we have a parameter s between 1 and 2. If we select S1, this part is removed, and we can select only by random. And if you select 2, this part is removed and you select only by rank, such as here. It is a fitness value only by rank, and it is a fitness value only by random or FPS, fitness proportionate selection. If you use S between 1 and 2, you can balance between ranking and random. It changed the selection pressure. Ranking has a highest pressure and random selection has a lowest pressure. 2 is the highest pressure and 1 is lowest selection pressure. It is the fitness or the portion of roulette 1, 4 and half when you use S1. If you use S2, it change to this, and if you use S1.5, it change here. So the portion of the roulette is changed because you can use the different issue. Another ranking selection is exponential. In the exponential ranking, we don't use a linear formula. You use exponential formula, and it is a exponential ranking, but it has some factors such as C. In this ranking methods such as previous, you rank each individual from 1 to mu last individual, and you can select the best value in the rank first and the worst value in the rank mu. Mu is the population size. Tournament selection. In this, two previous selection, we use all of the element, but in the tournament such as a sport tournament, we have member, not all of the member, and we rank elements. In this method for the tournament selection, we pick number random, then rank them or select the best of this. It is such as tournament. If is 2, we select the best for the next, then select for the next. It is a tournament in the with size of It's a tournament selection. Each time you select element randomly, then select the best or highest fitness for the next generation. Tournament selection with equal to 2 is the same as some football or club that 2 teams have a game and one of them eliminate, then also 2 teams have the game and one of them miss the match for the next, and also we have this for the next stage, and it is a final. It is a tournament of K equal to 2. It is one of rank selection, but we don't select all of the elements. Another selection in each EA is survival selection. Survival selection most of the time is based on age and also based on fitness. The survival selection based on age is mean that we delete parent or select offspring for the next generation. But the fitness based is such as previous selection, such as FPS, SUS, RWS. We select based on fitness, not based on age. So it may select parent, both parent or offspring or children. To a special case of survival selection is elitism. Elitism is mean select the best element. So we have a population combination of parents and children. So we calculate the fitness of all of the parents and children and select the highest fitness. The highest fitness may be from parents or maybe from children. It is named as a elitism. Elitism is named as a very high quality element or very high uh, fitness element. This another method is genitor. Genitor is delete worst. Each time we calculate the fitness of the all of the population and delete the worst or lowest fitness. It is a steady state algorithm because only one element uh, replies in each loop. But in elitism, we can use as a generational or steady state method. In the elitism, it is guaranteed to keep the fittest or highest fitness value. These two type of rank based or two type of survivor selection that use fitness based selection.